Welcome to English for Professional Mechanical Engineers. My name is Huang Dongyong. We finished the first two parts of Introduction to Arduino, and I'm going to continue the next part in this video clip. In the beginning of the third part, I'm going to talk about the session where to start. If you have no idea about where to start, I suggest you first get an Arduino Genuino starter kit as shown in the bottom left. The starter kit is a great way to get started with Arduino, coding, and electronics. The starter kit includes the components shown in the bottom right. You may make 15 fun projects following the step-by-step tutorials on the project book. When you are equipped with hardware, you'll need software to make it work. Go to Arduino homepage, www.arduino.com. Click on Software. Now you have two choices. Either access the online IDE to use Arduino Web Editor, or download the Arduino IDE to use the software offline. I personally prefer to download the Arduino IDE to my PC, so I use it as an example. After download, I got the executive file, e.g. Arduino-1.8.5-pwindows.exe. Run it to install the software. Please note that 1.8.5 is the version when I made this video clip. You might get a newer version at the time you download. Now, let's proceed to the programming part of Arduino. We begin with the big picture of how to program the Arduino Uno R3. Most microcontrollers are programmed with some variant of the C programming language. So is Arduino. The compiler software is hosted on a computer separate from Arduino Uno R3. The job of the compiler is to transform the program provided by the program writer, namely filename.c and filename.h, into machine code. It asks filename.hes, suitable for loading into a processor. Now the figure shows what's going on in the Arduino IDE. It runs on the host computer, for instance, my computer. The Arduino development environment provides a user-friendly interface to aid in program development, transformation to machine code, and loading into the Arduino Uno R3. The code is a C compiler. There are two tasks inside the C compiler. First, it compiles files with extension name .c and .h to an assembly language file of extension name .asm. And .asm file would be generated only when there is no syntax error. When the program source file contains incorrect use of C, the compiler reports these syntax errors to the user. An assembly language program .asm file is not generated until the syntax errors have been corrected. Second, it assembles the .asm file to file of extension names .hes and .eep. Now, I'm going to talk about Arduino programming, which you might be nervous. It's based on C++, which means to be an awesome programming language. But don't panic. It is greatly simplified by eliminating most unused complex instructions and providing succinct new commands. Programs are called sketches with extension name .ino that will be converted to .c files in Arduino IDE. There are two necessary functions in sketches. Function setup runs first and once, and the function loop runs over and over until power off. The figure shows the minimum Arduino program with two required functions, setup and loop. The status and syntax errors after compilation will be shown in this entry. As mentioned in the previous video clip, you may choose a variety of Arduino boards. The default board in the sketch is Arduino Genuino Uno. However, you can click on Tools, pull down the menu, and click on the board to choose the right one you use as shown here. Comments. Remember to put comments during programming. There are digital signals and analog signals. It's easier to understand digital signals than analog ones. And the digital input and output commands have been simplified in Arduino IDE. Hence, I explain digital signals and digital input-output in the following slides. There are only two states of digital signals, high and low. Alternatively, as a result of switch action, on is preferred than high, and off is used instead of low. In the binary world, 1 is used for on, and 0 for off. Voltage signal for high will be a little less than 5 volts on your Uno, and voltage signal for low will be 0 volt on most systems. In order to use the digital I/O interface of Arduino, we have to make sure we use the right counterpart in the software for the chosen hardware. First, you might determine which pin to use for digital input-output in the hardware part. Then, in the software part, you have to assign the pin mode as input-output within the setup function, and execute the read-write commands within the loop function. Now, let's check the hardware for wiring. There are 14 digital input-output pins, numbered from 0 to 13, and labeled digital in Arduino Uno. When you connect digital sensor for input or digital actuator for output, you have to grant name to the digital GND pin, which is next to digital I/O pin 13. PWM technique is frequently used in dimmer and motor control. Next to the label digital on the board, it reads PWM tilde. You can check that this is a tilde sign before pin numbers 3, 5, 6, 9, 10, and 11. This indicates that these pins can be used as PWM outputs. Now, the software part. First, use the built-in function pin mode to assign the pin mode as input or output within the setup function. The syntax is pin mode with arguments in the order of the desired pin number and the mode, and ends with a semicolon, where the pin number ranges from 0 to 13, and the mode is one of the following actions: input, output, and input pull-up. Please note that all letters in the argument mode should be in capital. Second, execute the read-write commands using the built-in function digital read and digital write, respectively, within the loop function. The syntax for digital input is digital read, with the assigned pin number as the argument and ends with a semicolon. And the syntax for digital output is digital write, with arguments in order of the assigned pin number and the desired value, and ends with a semicolon. Where the pin number is assigned in pin mode, and the value is one of the two actions, high and row. Please note that all letters in the argument value should be in capital. Here is an example of digital output. A project to make an automatic blinking LED after power on. It's important to finish a project by completing one doable piece at a time. I hereby provide this tiny project to 3 steps. Step 1. Test LED circuit with 5V source. Step 2. LED on using Arduino's DO. Test if the digital output works normally. Step 3. Automatic blinking after power on. Set LED on and off using delay. In step 1, the LED circuit test. A 220 ohm resistor and a red LED are used. The color code of a common 220 ohm resistor is red, brown, gold. Note the long lead of an LED is anode and the short lead is cathode. We use the 5V power on the Arduino board as shown in the schematic. One end of the resistor is connected to the 5V power pin and the other end is connected to the long lead of the LED. Then, the short lead of the LED is connected to the GND pin next to pin 13 to complete the circuit. In step 2, LED on using Arduino's digital output. Digital I/O pin 13 is chosen. Hence, in hardware part, the schematic and layout show that instead of the 5V power pin on the Arduino board, the resistor now is connected to the digital I/O pin 13. Now in software part, we assign a constant name LED pin to pin 13. Then, in the setup function, use the pin mode function to set LED pin in output mode. And in the loop function, use the function digital write to set the value as high. That is, the output voltage is about 5V. It's better to try to see if it works. Click on the check button to verify and compile the program to machine code. After successful compilation, click on the rightward arrow button next to the check button to upload the machine code to the Arduino board. Congratulations, you set to work successfully. Before we go on to step 3, let me prepare you with one more useful command, delay, which will be used in step 3. It's one of the must-know commands. The syntax is delay with integer argument whose unit is millisecond or ms. We are going to complete the blinking LED project. In step 3, we'll set LED on and off in turns, each for 1 second, as shown in the flowchart. This figure shows the commands within the function loop. First, set the LED on and wait for 1 second. Then, set the LED off and wait for 1 second. The loop will repeat itself over and over when you turn on Arduino. Again, you just verify and compile the program, then upload the machine code to your Arduino. The project is done, and you can have a blinking LED now. I've shown you some basics of Arduino. Finally, the next session, references. For your information, I give you the references. That's all for introduction to Arduino. Hope you have got some ideas about Arduino now. Thank you for watching. Have a good time and see you